Sweet. Oh, all right. Thank you, as always, Tiffany, for rescuing me. I appreciate it. Let me see. Where's my camera? Okay, good. Right on. Okay, so, apologies for that. That's entirely my fault. I'm not very good with the technology, so I'm just very happy that we got online. Thanks to Tiffany. Thank you so much for that. And to everyone else watching, why? But I appreciate you being here. So I have no idea why you're here, but I really appreciate it. We're going to cover, I don't know, we're going to look at proxies. There's a lot of really interesting things in the world of proxies. Now, proxies are a very specific feature in the Spring ecosystem. You may not know about them or care about them, but that's precisely the point. There's just some interesting stuff to look at here. So we're going to create a Spring native application. And that's it. We're just going to create a Spring Boot application that turns into a native application. Downloads. And this is just me exploring some proxies. I just wanted to have you over my shoulder as we looked at different features in the Spring ecosystem designed to support proxies. Now, let's go over some basics here. Let's go over what a proxy is. Proxy design pattern. Okay, in computer programming, the proxy pattern is a software design pattern. A proxy in its most general form is a class functioning as an interface to something else. So basically, it's like a network proxy. It's a relay. The message arrives at the interface, which is the type, the shape of the type, and then that gets forwarded downstream to an actual object. And the proxy could interface to anything else. So if you've ever used, you've got a type and you invoke a method and that results in a network call being done, like through RMI, that's a proxy, right? If you've ever invoked an object and you've gotten some side effect, such as with aspect-oriented programming or transaction demarcation or logging or measurement or observability or tracing or whatever, any of these things that can happen as a side effect of invoking a method, that is probably a proxy. And you do this because you want to make some external system look like an object, right? And you can also make other objects that don't have particular responsibilities. You want to make an object that looks exactly like that other object, but that has this extra logic to support these extra responsibilities, right? And so let's see. The access to the object should be controlled. Additional functionality should be provided when accessing an object, right? So it should be possible when accessing sensitive objects, for example, it should be possible to check that clients have the needed access rights. So this is one of those things where you can do that through proxies in Spring and Spring security. You can do @pre-authorize and so on. So let's take a look at just the general discussion of proxies. Okay. So let's just forget about Spring Boot for just a second here. I'm just going to remove all the fun. We're just going to do some basic programming here. So suppose I've got a default customer service. Okay. And this is just a type, and I've got an interface called customer service. And here I've got the ability to, what's a good example? Jeepers. String get message. Okay. So get support message, I don't know, whatever, just some string, okay, just some arbitrary string. And so this default customer service implements customer service, and that in turn results in this type being required. I have to implement that type. So I've got a class here that's hello world, and just whatever, get message. Okay, just call this simple. Forget about the domain. It really doesn't all that much matter. What we care about here is just something that gives us a message, okay? And get message, huzzah, okay? So we can actually, let's say I have a pointer to that. I can say simple service equals new default customer service, okay? Well, let's suppose now that I want to protect this request from, in secure invocation, unless I want to have it secured. I want to lock it down. I want to make sure that somebody can't call that method unless something is done. So here I could create a proxy. I can do it manually, right? So here I could create a authentication checking, proxy simple service, right? And so this is going to implement simple service, and I'll have a target, simple service target, and it's otherwise just going to implement the same interface, but only if a certain check has succeeded, right? So I'll have some sort of, let's assume there's some well-known static final atomic reference, atomic Boolean, authenticated, okay, new atomic Boolean, false. Okay, so here I'm checking to make sure that if some flag externally has been checked, if Proxies application dot authenticated dot get, then we allow this to go through. We return a custom message, hello secure world. Okay. Else we return the insecure default message. Okay. Or maybe it's the other way around. Maybe the actual implement. Yeah, that's fine. Actually, that's a good way to do it. So we have this very simple proxy. And so from the perspective of my code, I have this simple service, but I want to secure it. So I'm going to create another simple service, proxy, that uses the new authentication, blah, 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 pointing to that, okay? So now from my client code, I would just use the proxy version, right? I don't ever need to know that there's actually another wrapper there, right? So string message equals this. Let's print that out. The message is message, okay? Let's run this, see what we get. Okay, so we got hello world. Now, what happens if, let's say there's a filter or something like that, something has been done so that we've authenticated, right? And I'm not going to reinvent Spring Security for our demo here, but suffice it to say, imagine now that there's also, authenticated set, authenticated dot set is true, and then we start this. Okay, now we got the messages hello world. So here I'm proxying the underlying service, the actual service, and I'm doing it in terms of this interface. The fact that the consumer code, like if I wanted to do, I could actually write a method. I could say static void use service, right? And all I care about is the pointer to that simple service. And so all this business logic, all this business logic can happen here, and it doesn't care about the sort of machinations that have happened beforehand. It doesn't know or care that I've created this this proxy behind the scenes. It just knows it has a thing that walks and talks and quacks like a duck, right? It knows it's got a simple service. So the proxy pattern is very useful. And in Spring, we use it all over the place, right? In Java, it's available all over the place, right? So actually, let's go a step further. Let's clean this example up here a little bit. So instead of just using I've just done this the long way around, let's use this in Java. There's actually support for doing this kind of thing in Java as well. So let's say now, I wanted to do this with Java. So here, we're going to create static class, simple service. Let's start static, simple service, create a manual proxy wrapper, right? Simple service, okay. And this is just the logic here. I'm doing all this without Spring so far. All this is just so you can kind of see how these things fit together, okay? So one way I could have done that is to create the manual wrapper like we just did. So here I have a pointer to a simple service. Because it's hidden by the factory, I don't really care about the machinery that's involved in creating that simple service. I just know I have something that it has the shape of a simple service, and I can treat it as such. But what if I want to do this with JDK proxies? Because the JDK actually has a mechanism for automatically creating proxies for you as well. So create JDK proxy. And here, what is this? It's a Java proxies. Okay, dynamic proxies. There you go. Proxy dot invocation handler, proxy dot get class, and voila. Okay, so here I'm going to create my own invocation handler. So it's using Java lang reflect proxy. And we have to create a new invocation handler. Okay. And it's a callback method there. And here, the invocation handler is kind of cool. It's like you're registering an event listener for a type, right? For methods being invoked on a type. So here, I'm going to say a get proxy class. Oh, what's the issue here? Why is it deprecated? Why? Tell me why. Oh, new proxy, deprecated. New proxy instance. Okay, that's fine. New proxy, yeah, sure. Great. I don't know why that's different, but who cares? Okay, so what you do is you provide the class loader, system.get class loader. Oh, class loader dot get system class loader. Okay. Or you could just usually you can get the class loader by accessing the class loader of the type that you're trying to proxy. That's not always true though, right? The class loader of the type you're trying to proxy might actually be different. So that's why they give you this. In our case, it should be the same. And then the kind of proxy that we're going to create is a proxy of type simple service. So what this will do is it'll create an object. Let's see, class T. What is this issue here? Class loader and then class. Oh, it takes a class loader, right? Class loader. Then it takes interfaces, new class, and simple service.class, and then finally it takes the invocation handler, okay? That should do it. Is that not true? There you go. So what we get back is a object that now you can cast, hopefully safely, right, to simple service. And what's going to happen is if I call methods on this proxy here, like this, proxy class.getMessage, it's going to then invoke, me calling this method is going to result in a method over here being invoked, right? So you'll see calling method.getName with arguments, args, on proxy.getClass, okay? So we're going to then invoke the method. We'll say method.invoke proxy args, right? The problem, of course, is that you shouldn't really pass in proxy because proxy is going to be just a no. It's not real. So we need to have a target, right? And so here's where you have that target that I created before. Here's my default one, right? So static. There you go. So the target in this case, the one I'm delegating to, is that one. I'm forwarding the invocation to the original one, right? But again, like the consumer of this type won't know the difference, and they don't need to. So this is an event listener, replace with a lambda. Great. And let's use it just like we would before. So let's return that, return proxy class. Now we go down here. And
no one can see your screen.
Sorry?
You're not sharing your screen.
I'm not?
No.
Well, that's awkward. So this entire time, nobody's been seeing my screen? That's good. That's good. Wish somebody had told me that. That's a little embarrassing for me. Okay, let's try this again. This time with more gusto. So it's quite the mess to untangle thus far. All that code gone, so gone. Okay, let's try again, people. Sorry about that, my fault. So we have public static void main, right? And we have an interface called customer service. And this customer service has a method called get message, and that returns a string. So we're gonna have a simple default customer service implementation of it. Okay. And this is going to be just a default hello world, right? But now I want to have a proxy. I'm going to demonstrate basic proxies. Okay, I'm going to just start from 0 here because I want to make sure we're on the same page. So we're going to start from 0. I'm going to create a simple proxy that actually does some sort of authentication. Okay, so I'll have a static atomic boolean authenticated equals new atomic boolean, and this is going to be false by default. And I'll say, okay, default customer service equals new default customer service. This is actually just, you know, a service, right? Whatever. Target. And I want to create a proxy that checks this authentication flag. And if it's true, then it'll actually return a privileged message, but otherwise it'll just forward to the underlying thing that's being proxied to do its work. And a proxy, as I said before, is a thing that just acts as an interface to another type. So, you know, the design pattern here, you know, it comes from the Gang of Four design patterns book from 30 plus odd years ago, and longer than that almost now. And the idea is that it's just an interface. It sits between you and an underlying object to ensure, to add some responsibility to an object or to hide some aspects of the backend implementation, right? So here's my default one. I can use this. I can say target.getMessage, and I can just var message equals, print that out, message, okay, message, okay? So there's my basic use, my direct use of it, but I want to introduce authentication. What I could do is I could say, okay, well, you know, if authenticated.get, then, you know, I can say that the message should be something else, but I want to actually have this as a decoration so that it doesn't have to be repeated for every user of this type. I can actually have this as a decoration around my target service here. So what I'm going to do is I'm going to create a authenticating customer service that implements customer service, and this will be a proxy, right? This will be a thing that actually does the work on the underlying customer service implementation here. And so I'll inject that into the constructor, and let's see here. We're going to say if proxies application dot authenticated dot get, then return hello secure world, right? Otherwise, return the target, this customer service dot get message. So it'll return a secure value if the user's authenticated somehow, but otherwise it'll just forward to the underlying default insecure implementation. And that proxy adds that extra responsibility there. I can do something different, but from the client's perspective, they're not going to know because all they're going to have a pointer to is a customer service. And so we can see that in action here. We can say wrapper proxy equals new authenticating target. Voila. Okay. And we're going to say wrapper proxy, blah, 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 get the message. Okay, good. So let's see what happens. We should get the insecure default message here. Okay, hello world. Now let's use the wrapper by saying authenticated true. Okay, take 2. Okay, hello secure world. So that's worked as well. So now we have a very simple manual proxy, but as I was explaining, you can do this in the JDK as well. So let's move this code out, build manual wrapper or manual proxy. Okay, and I'm just gonna move all that here. And we're gonna have this be a static thing. Right. And we'll return proxy. Okay. Now we've got proxy customer service CS. Great. Okay, so set authenticated is true, get the message with the manual proxy. Now, can we do this with the JDK? Well, yes, we can. The JDK has something called an invocation handler. And so let's use that instead. So here, static customer service, build JDK proxy, okay? And here, we're gonna say customer service. We're gonna create a proxy, new proxy instance. We're gonna use the system class loader, right? Class loader dot get system class loader. We have to provide an array of classes. And so in this case, the class is gonna be customer service dot class. And then we're gonna provide a new invocation handler. And this is a little bit more about why is this? Something's rattling on my desk. Okay, so what this is going to do is this is a callback, right? So what this gives me is a object that has an event listener in effect for any method that you invoke on the resulting object. So here, what I'm doing is I'm creating an invocation handler. Let's actually extract that out a little bit here. Invocation handler. And I need to invoke the method against an actual concrete object. I can't just use a proxy. So I'm going to pass in the args, but I need a concrete object. Well, that's the target. So I'm going to say invoke it against target, which has the same type as what we're asking for here. We're saying give us a new proxy of type customer service, and then use this handler, right? So the handler is the invocation handler, and then return that. And so here I'm going to say simple service, customer service. Voila. Okay. Okay. So we've got now invocation handler, the class loader, and the proxy instance. The proxy instance, as you can see, is a customer service. It's got the same shape as a customer service, but we've rewritten it to now have our quote unquote security, right? Proxies application dot authentication dot get. If that works, we want to use that. If not, we don't. So actually, we can return a proxy here. Actually, that's a good idea. Rather than rewriting this logic, I'll just return. I'll create a proxy object here. So we'll say manual proxy. Return that. That's this right here. And then this will be the target. And there you go. So now we're going to just forward all method invocations to that proxy instance. Okay. So pretty straightforward. It's still a simple. It's still a customer service. It's just the user won't ever know that. They'll get back an object that behind the scenes forwards its invocation to this other type. Okay. So let's try that out. Okay. So we've got this build manual proxy. Seems to work. Let's do build JDK proxies. Hopefully that one works as well. Okay, hello secure world. What about false? Okay, good. So you can see that's working as well. So we're actually creating a proxy using the JDK proxies mechanism. Now, the thing that is common throughout all this is I've got this interface, right? And the interface is the shape of my thing. But there's a lot of times where you want this ability to do what we're doing, where we enhance a class, we enhance a type by introducing new responsibilities to it. By using proxy. We do that a lot, right? But there's other things you might want to do that on as well that, don't have interfaces necessarily, right? So for example, let's say that I created a simple service, just a class, my secure customer service. Like, why do I need the interface here? Why did I create the interface in the first place? I don't need the interface. The interface is it's just, I don't know, we just did it, right? But we don't, hello world, why can't I just have this work? Why does it have to be a customer service? Especially since the kinds of decorations that you do with proxies, they can be reused on any method, on any type, right? They don't have to, that doesn't mean that you need to have multiple implementations. Usually you create an interface if you have the possibility of having more than one implementation of a thing in the system. But if you're only going to have one, then, why have the interface, and why would you need that? I think Spring shouldn't be telling you to create an interface just so that it can do its work for you, right? If you want transaction demarcation, for example, you shouldn't have to create an interface for one implementation to get it. I mean, it's always a good idea to cleanly delineate your component boundaries and all that stuff. And there's a whole discussion around the benefits of having a contract and message passing and all that, but technically it just seems weird, right? It's a little fishy that has to be done. So let's revisit this discussion. Now, what if I wanted to proxy this concrete class? Okay, so let's throw away this old code here. Static interface based proxies, right? Static void, there we go. So that's just one example here. But what if I wanted to have like a concrete class? What if I wanted to introduce new behavior that acted on every single method in this class? Well, you can't really use JDK proxies because they require an interface. They don't give you an actual concrete class. They give you a handler based on invocations of methods on an interface. That's all. And so the best you can do is to forward those invocations to another object of the underlying type. And by the way, it supports multiple interfaces as well, right? So if I had given the JDK proxy code back here, multiple different interfaces, the resulting object would implement all those interfaces. It would be the same. So I could cast it to any of those interfaces as well. But it still doesn't have the type of the underlying thing. And that's sometimes very useful, especially in a world where you've only got one underlying thing. You've got a concrete implementation. You don't have any interfaces at all. And that's the whole point with Spring, is that the protocol, you don't have to be so rigid in the protocol. It's plain old Java objects, right? So let's say I wanted this bean, this regular object here, to have some extra responsibilities. Well, I could do this. I can tell you how you would do it manually, right? You'd say authenticated, my secure customer service extends my secure customer service, and then you just override it, right? So I do the same thing as we did before, where we'd say, okay, if proxies application dot authenticated dot get return hello secure world, otherwise return super dot get message, right? So that's kind of what you do. You'd override every single method and install this check, right? So what if I wanted this check? Right now, this check applies. It's kind of a willfully overzealous, right? My current logic, my delegating proxy, my authenticating customer manager, that will apply to every method that you invoke, including equals, right? So this makes no sense. I should have done a little. I should be a little bit more. Where's my code? Where is that logic here? In the invocation handler, you'd want to make sure that you tested to make sure that you're not calling the wrong methods. Like if you called equals and toString and all that stuff, that implementation would definitely fail. It would be the wrong version, because the return value should have been like here. It should have been like if it's, where's my invocation of the handler? In here, the return value of method.invoke should be whatever is expected. So obviously I'm just assuming that you're going to always call get message, but if you called toString or equals, whatever, those would fail because I'm just returning hello secure world instead of Boolean and string and whatever else is required, right? And so you should definitely inspect the message, inspect the method. You say if method dot, oh yeah, this. If method dot get name dot equals get message, then we can return that, that kind of thing. Otherwise, you just return method dot invoke or something like that. Okay. Actually, no, that's not even very sound code there, is it? I've mixed two things together. So let's just fix this up a little bit. I'll get rid of that proxy for the JDK example to make it a little bit cleaner to understand. So the invocation handler is rewritten as such. If if method.getName equals get message. Okay. And otherwise return. And if the proxy is authenticated is true, then do that. Otherwise, just return method.invoke on the authenticated customer service with the arguments. So there, that should work correctly. So I'm only doing the if authenticated thing for the get message invocation. Okay, that way it's limited now, more correctly limited, more correctly scoped. Okay, so the same is true down here though, right? This authenticating my secure customer service. If I wanted that same bit of indirection, here's my original concrete class with no interface, and here's my proxy, but it extends this, so it has the same relationship as a proxy in that it is a customer service. It has the same type. It's just that it's overriding this. Now, of course, that doesn't work if these types are final, right? That's not going to work. I can't extend this in my code. And so let's see what that looks like here. If I go here, I want to say my secure, that's the concrete type proxy, right? And the proxy is actually a new my authenticated blah, blah, blah customer service, right? So I'm actually extending the type. And again, from the perspective of my client code, it would not know that anything is being done there. It doesn't need to know. So for example, where's my, I guess I could just call this static void use concrete customer service, my secure. Okay. And I can just call customer service.get message and print it out. Message. Okay, so there's that. And again, the code doesn't need to know that there's an authenticated version. So that's very convenient as well. We've got proxies in both cases. They're both doing the authentication, but you can see they're very different approaches. For interfaces, we can use JDK proxies. For like concrete types, things aren't so automatic, right? We don't have an automatic way to do what I just did. I had to manually extend the class, and that's not very cool. In Java and Spring Framework 3, rather, in 2009, we introduced something called CGLib based proxies, right? Or concrete proxies. And so now actually, you can rewrite all of this. Let's just say we've got let's rewrite all this now to get rid of. Do I want to keep all this? Let's just get rid of all. Put all that over here. Okay. Okay. Okay, there's this. So there's my cleaned up code. Public static void main. We've got our authentication. In Spring, we can actually help you with this. We can actually create proxies of both types. And the venerable ProxyFactory bean will help you with that. Actually, we even have a thing called ProxyFactory, which you can use, right? It's easy, right? So you give it a proxy interface, and you give it the target. So let me see, do I want to do that? Or I want to use the ProxyFactory bean, BFB. Okay, ProxyFactory bean dot set target. So I'm going to provide a target. So I'm going to provide a class here, a concrete class of customer service, right? This is my default customer service. And I want to have a method here to get the string get message. So here I can say, okay, dot class, ProxyFactory bean dot add advice. So new method interceptor. And this is the AOP Alliance method interceptor. Method interceptor. Thank you. Okay. AOP Alliance type. It's been around forever. It's again, this type was supported in Spring. I think 1.0, right? Like it's part of JDK. It's part of we could do this even with JDK proxies. This would work. So the wrapper, the abstraction says, okay, add an advice. This is like the invocation handler. MI, and here, same as before, right? You'd say, okay, well, if authenticated, get then return and also if mi.get method.getName dot equals get message, and if it's authenticated, then return hello secure world, right? Very simple. Otherwise, we want to forward the invocation to just onward. So we can just say mi dot proceed, right? And that's the same as what I showed you earlier, where I'm just actually manually invoking the method myself. And so this is it's the same basic approach, right? I'm doing the authentication for this particular method on this type. Okay, so let's say return hello world. Okay, so let's try that now. Let's see if that works. So what does that give us? ProxyFactory mean get object object result, and then you can cast it down. So you can say default customer service result, and then we can do default customer service get message. Message. Okay. Let's run this and see what we get. Class cast. Oh, see, it's trying to create a default JDK proxy by default, but set target class. So this is what I did wrong. Set target class default customer service, and I'm going to give it a instance to a target object, right? So a new default customer service. So what it's going to do is it's going to invoke this method interceptor whenever I call a method on the type that I've given it. In this case, the type is default customer service. So that's the shape, the outside shape, the protocol that I'm going to have. Behind the scenes, because I've given it just a concrete class with no interfaces, it's going to dynamically extend that class, right? And do as it did before. Okay, let's see here now. What did I do? Null pointer, blah, blah, blah. If target class, ProxyFactory set proxy target class is true. Okay. Where is it blowing up? mi.proceed. Let's put a breakpoint in here to make sure I didn't miss anything obvious. Advice is change. Refresh. I don't know. What did I do wrong here? It's now a null pointer in here. Okay, mi. Authenticated is false. Mi, reflective, blah, 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 proxies. Target is null. Why is the target null? Target is definitely not null. Okay. Yeah, okay, target is of class. Okay, so there you go. You're not supposed to have both of those types. Looks like it'll be better this time, hopefully. Yes, okay. So hello world we got that back. Now let's introduce a side effect here. So it's authenticated that set equals to true, and run this again. And then we get hello secure world. So we're doing the same thing, right? We're doing what we did before, but now it works for concrete types as well as JDK proxies, right? So behind the scenes, we use cglib to dynamically create a class that extends your class, and then we give you a reference to that behind the scenes, right? With this ProxyFactory bean. Or if you just give us an object and some interfaces, it'll create a proxy based on JDK proxies. Very convenient. Now, this is probably a lot more than you wanted to know all about the wide and wonderful world of proxies. What you need to know, however, is that proxies are central to a lot of things that we do in Spring. So, for example, let's say I wanted to actually do what I just did with real authentication, okay? So here's my, all that, good. Okay, so now let's actually return this to a Spring Boot application. We'll say Spring application.run, proxies application.class, and let's say I wanted to do aspect-oriented programming. Well, let's look at an example here. Desktop, Spring data, samples, security method, class, proxies, okay. So first things first, we're going to introduce Spring Security. And we'll do that by saying dependency, Spring Boot Starter Web, Spring Boot Starter Security rather. Introduce that, Maven reload project. And we'll introduce this Spring Security configuration for web apps. Let's go ahead and make sure we bring in Spring Boot Starter Web. I think I even started to do that and just walked away. Maven reload. Okay. Okay. Good. So there's our security configuration. We also want our, where did it go? There you go. We want a service that uses Spring Security. So here's this. And what this Spring Security implementation is going to do is it's a concrete type that has a method and another method that we can call, but only as long as the authenticated user is of type admin, right? And then finally, we want a REST controller. Okay. Okay, there's that. Greetings. REST controller, sure. Put that there, get rid of that. Okay, so now we have a controller and we have a service to which it's going to forward invocations. So if you go to hello, it'll call hello. If you go to the admin endpoint, it's going to call the admin endpoint, but only as long, excuse me, as long as you're authenticated, right? And then finally, we have this Spring Security configuration that installs two users, one with username and password, one with and the role user, and the other one with admin, right? So the admin should be allowed to invoke both methods, but only but the user can only invoke the first one, okay? And so I think that's it. It's everything we needed. Got all that, got all that. Yeah, good. Looks good. So let's run this now. Okay, it's up and running. Localhost. And we're going to call this, what do we call this? Hello. So hello. So it's going to ask me for a login. I can log in as username and password. So there yet, I'll just do this from the command line. It's faster. Curl minus username, password, HTTP, localhost 8080 hello. We're going to do minus V. So that gives us a 200, right? We get hello down there. Let's do the incorrect password just to make sure that it breaks. And there we get a 401, right? Authentication problem. So now what if I try and go to admin hello, right? Is that the URL? I think it is. I'm not sure. Admin. Hello. Okay, you can see it says forbidden, right? Closing connection 403. If I do admin password, however, I get goodbye, which is it's a 200 status code, so it's working. And the result of calling admin hello is goodbye. So there, I'm actually using a proxy on a concrete type, okay, which is cool. I mean, you're behind the scenes. That's what's happening. Is I'm annotating this, and behind the scenes, Spring is saying, "Oh, well, this is a Spring bean. I'm going to extend this dynamically when the application starts up and create a subclass, and I'm going to register that subclass in the class loader, and I'll create an instance of that subclass, and I'll return that." So even though we wrote this code, what's running at runtime when you call that REST controller, the thing that it's been injected with, if you look at that here, is a proxy, right? So let's go ahead and see what that looks like. Okay, so you can see we've got this thing called org cglib code generation exception, blah, blah, blah. I don't know what all that is, but you know, this is the type, greeting service. You can see this is not the greeting service that we created. It's a cglib. It's a class that was subclassed from greeting service imp. And that in turn has all this stuff that is meant to handle whenever we make an invocation on it, right? And so one of those things that it's doing is it's got a Spring security, you know, method interceptor, basically, something like that, that's checking that this method, whenever somebody calls it, has that credential in the context, okay? Now, what does this all have to do? Why do I care about this? Well, JDK proxies are part of the JDK. cglib proxies, like the one I just showed you, where it's a concrete type, that's you know, a thing that Spring does, right? It's a thing that Hibernate eventually learned how to do, and then it's a thing that other frameworks will do, right? And it's not that hard. There's things like there's frameworks like ByteBuddy and cglib and you know, whatever, right? You can do all sorts of interesting things with bytecode if you're a little creative and willing to suffer a lot of trauma, because it is not a fun experience. It's a terrible low-level API. But ByteBuddy and these things can make it a lot easier, right? cglib as well. But these are not things that are supported by the JDK, and therefore they're not supported out of the box in things like GraalVM's native image environment, right? So GraalVM, as you've seen me talk about in other installments of this series, it's a way to turn your Java artifacts into a native image, and it does that by foreclosing upon all the native, all the fun dynamic behavior you might expect from a Spring application, and it has. It throws away everything in the class path, including all the stuff in the JRE, including all the stuff in your code that you don't use, right? And it throws it away by analysis at compile time. Well, of course, this kind of stuff that we just did here, this funny business of creating subclasses and all that, it can't see that. It doesn't know that we're actually creating a new class at runtime. It just knows that this type here is compiled and therefore it's being used, or it actually knows it's compiled and being used somewhere, but it doesn't know that it should be that there's actually a proxy being created. So when at runtime Spring tries to create that proxy, it you know, causes GraalVM to puke. It doesn't work. And so you can give it hints. You can give it hints for all this funny behavior. And there's hints in Spring Native, our framework, for proxies, right? So you can say, okay, the type that I want to proxy is you know, whatever my service implementation. What do we call it? It's just a service down here. Greeting service imp, right? There's hints that you can provide and that we will use to then turn into configuration that gets fed into GraalVM. But as I said, GraalVM still, it doesn't know about cglib class proxies until recently. So Spring Native 0.10, you know, now has this support, and I'm showing you, the example I'm showing you is inside of Spring Native sample, so you can try it out for yourself. But now I can introduce a class proxy hint. So GraalVM doesn't know about this, but we do, and we can do interesting things with it in Spring before you compile your code. So we actually help you with this, right? So you say class proxy hint, and this is the first time Spring Native has a hint that doesn't have an analog in GraalVM, right? There's no JSON file called class proxies.json, but this works. So greeting service imp now, and then you can compile this just like normal. So let's do Maven clean package Spring Boot build -image. I don't know if we'll have enough time to see this work, in the next 2 minutes. Let me see if I can push back my meeting here. Come on, go faster. So this typically takes several minutes, right? So this new feature is really cool though. I'm just so pleased that that works. So now whole swath, like basically the goal of Spring Native is that you can bring your app unchanged. Now imagine what you can do with when even this kind of stuff works just out of the box, right? Right now we're doing it manually because I'm doing, we're teaching Spring Security here about it, but the goal is that this kind of dynamic hint will be enabled in the programmatic hints that we ship with Spring Native. So you won't even have to do anything. It'll just automatically find types that have this and that are interfaceless and just automatically do it. Same thing for AOP, aspect-oriented programming. If you're doing raw, like regular, if you're creating an aspect, a Spring AOP aspect using aspect J, that'll just work, right? All these kinds of things should just work. Almost there. Oh, come on, go faster. Compilation with Spring Native is not its strong suit, not its forte. This takes forever, and of course, it's right at the end of the screencaster. I should have gone a little bit faster. I think I probably would have. We started late, and that was definitely my fault. And then, I wasn't sharing my screen. That's definitely my fault. But to be fair, I'm not used to streaming live from Zoom. I'm used to doing meetings, and there's an obvious prompt there to share your screen. But either way, my fault. We started off so much later than we should have been. This would have been done. I hope people joined right as we started the second round of, as we started revisiting the stuff with the screen being shared, because that was a coherent-ish demo. Come on. Almost there. Oh, nearly. 7 gigs of RAM. Okay. Very good. So there's my proxy, Docker run p minus 8080 to publish the port. It's a Docker image. Oh no, what did I do wrong? So anyway, I've clearly forgot to do something special here, and we don't have time to fix it, I'm afraid, because I have to go, and I'm sure somebody else needs to use the stream. But I want to thank you all for hanging out with me today. All this, I'm sure the correct fix is in here somewhere, right? In this security method class proxies. The error I just experienced has nothing to do with what I showed you. It has to do with something I perhaps added that shouldn't have been on the class path. Did I do anything obvious here? Spring Native, Tomcat, programmatic. Oh well, I'm sure I'll figure it out later. Either way, thank you so much everybody for your time. I hope you have a great day. Stay safe, stay healthy, etc.